Hello, this is a demonstration of my final project in my AI course in my university to perform path anomaly detection using hierarchical temporal memory. And on the left, you see a red circle revolving around the center. It's the object we are trying to track. And on the right, you see three white squares with blue dots in them. Those on the top is the input to the algorithm. On the middle, it's the algorithm has learned, and on the bottom is what the algorithm hasn't learned. And under that is the anomaly score history and the score itself. The history shows, well, the history, and the score is how horrible is the algorithm performing, or how weird the path is now. And it will be how we evaluate the algorithm on detecting how hard on the path. And with that out of the way, okay, the algorithm has just started learning, so you see the anomaly score is quite high, and for the sake of time, we'll be accelerating this process, and it shouldn't take more than a few seconds for this anomaly score to drop down to acceptable ranges, which is like now. The algorithm learns really, really fast. Now the anomaly score is really really low, and we could try and inject anomalies into the path now, like I don't know, maybe move to the right by 50 pixels, and you see the algorithm immediately recognizes that the anomaly inside the path and generate a very high score. Now we can try other things like, well, change the center of the circle, revolution, and the algorithm again immediately generated a very high score, indicating this is not an ordinary path that the object is taking. And we can try to reverse the direction of the circle, and again it generates a pretty high score. And now we can move the circle to a fixed point, and again it generates a very high score immediately. Now we can try slightly minor anomalies, like moving the circle to the right 5 pixels, and 5 pixels, and again immediately the algorithm finds the anomaly and generates a score that indicating that the path is weird. And we can enlarge the radius of the revolution by 5 pixels. Again, the algorithm finds that this path is weird, and it's not the ordinary path, so generating a lot of anomaly score. Now we can, besides generating anomaly, this algorithm could also learn multiple paths without forgetting the previous paths. So we could move the circle to another place and force the algorithm to learn the new path. And for the sake of time, we'll be accelerating the process, like so. And as you see, the anomaly scores start to drop immediately and pretty rapidly. And within a few seconds, it has dropped from 100% to something around 20% and still lowering. And I think this should be enough training, so we could stop training. And as you see, the algorithm now recognizes this path as a normal path, and we can set the circle back to the original location. And again, the algorithm thinks that it's an ordinary path, but seems to think it's a bit weird. And that's okay, we could always force the algorithm to learn again. And now the algorithm has relearned it, and it thinks that it's a normal path again. And now we could switch the circle between the two paths, and the algorithm will think both of the paths are an ordinary path. So now we can switch it back, and it's still a low score. But as you see, when the circle switches between the both locations, the algorithm thinks that still generates a pretty high score, indicating that the ball shouldn't be able to switch between the two locations, which is what we expect as ordinarily at that location the ball should revolve around a point, not switching between two places. That concludes the demonstration.